Okay, here's a chapter 2 test review. It's pretty long. It's a lot of stuff about a lot of different types of functions that we have all in one chapter. So get your memory primed. Okay, starting with characteristics of the polynomial function. Remember, if it's not in standard form, you have to find the leading coefficient, which is the one with the highest degree exponent. So the degree of this would be 6. The leading coefficient is positive 8. So if this is an even degree and a leading coefficient that is positive, then we know that the shape will be like this, up, up. I guess it technically wouldn't necessarily be a parabola, but it would be like this, up, up. So our end behavior to the right as x approaches infinity is infinity, and to the left is also infinity because it's going to be up, up. Okay, the number of possible zeros is the same as the degree, so it's 6. And the number of possible extrema is always 1 less than the degree, so this would be 5. Okay, number 2. Looking for our leading coefficient in here, that would be this. So the degree is going to be 4. The leading coefficient is positive 1. And then the end behavior and limit notation. So again, this is positive even, so this is going to be up, up as well. So the limit as x approaches infinity, not 8, infinity of our function is going to be positive infinity, and the limit to the left as x approaches negative infinity of the function is going to also be positive infinity because it's going up on both sides. So the degree is 4, the number of possible zeros is 4, and the possible extrema is 1 less than the degree, so 3. Okay, number 3, we are going to sketch a graph for each polynomial function. Let's start by identifying end behavior. So add up all the exponents. 1 plus 2 plus 1 will be an even degree. And then to find the positive or negativity of the first coefficient, just multiply each of the first terms. 1 times 1 times 1 is going to be positive 1. So this is even positive, so we have another end behavior like this. And now we need to use the roots. So we are going to have 3 roots because we have 3 factors. Set each equal to 0 and solve. We will have 1 at 2. We will have 1 at 4. And we will have 1 at negative 5. So I can plot each of those here, negative 5, positive 2, positive 4. And then noting the exponents. This has an exponent of 1, meaning it will cross the x-axis at that point. This has an exponent of 2, meaning it will bounce off the x-axis at that point. And this factor is 1 again, so it will cross. Start with your end behavior. Because we know this is going up, up, we can start with those. And then we know at negative 5 it's a cross, so it's going to go through here, negative 5. Then at 2 it crosses again. And then at 4 it's going to bounce back up. So this is a sketch of what this graph would look like. Okay, so then number 4, this is not in factored form. So what you need to do in order to see the behavior at the ends is to factor and get it factored out. So let's factor out a negative x squared from both of these terms, which will leave us with x minus 6. Now we have this in factored form. So if we set each factor equal to 0, like this, square root both sides, square root of 0 is 0, divide both sides by negative 1. So we have 1 root at 0, and it is squared, meaning that it will be a bounce at 0. And then our other factor set equal to 0, x minus 6 equals 0, and solve. X equals 6, the exponent of this was just a 1. So this is going to just be a cross when x is 6. So I plot that here. The other thing that I want to determine is my end behavior. So I can check the degree. And this one, because it wasn't factored, we can see the leading term right here. We can see that our exponent is odd and our leading coefficient is negative. So we know that odd negative will be falling from left to right, like a line with a negative slope. So if we start with our end behavior, this one's going up to the left and then down to the right. And then knowing that we have a bounce at 0, we know this is going to go back up before it comes and crosses over at 6. Okay, these ones 5 through 9, you will actually not have this many. This is one case when the review is actually longer than the test. but I wanted you to see possible scenarios that could come up so that you know how to do all of them. I'm picking and choosing which ones I give you on the test, but I wanted you to try all of them so that you know how to do it when you get to the test. So we're solving for all the zeros, so we need to find every single x that this could possibly have. This is quadratic, number 5, so we can use our x method. Check if there's a GCF. If there is, we have to factor it out, but there is not. So on top, we get 5 times 6 is 30, and b is negative 31. So my two factors are going to be negative 30 and negative 1. And because a was not 1, we have to divide both of these by 6 and then simplify if we can. So negative 30 over 6 simplifies to negative 5. So my two factors are x minus 5, and bottoms up 6x minus 1. Set equal to 0, so if we set each of these equal to 0 and solve, we get that our two roots are that x equals 5 and x equals 1/6. Number 6. This is a difference of perfect squares. So we will start by factoring in our form of difference of perfect squares. The square root of the first term, square root of x to the fourth is x squared, minus square root of the second term, plus square root of the second term. And then these both equal 0. We need to solve for both. So if we set this one equal to 0, add 4 to both sides. So we get x squared equals 4. Square root both sides, and when we square root both sides, we must take both the positive and negative possibility of that square root. So x is going to equal plus or minus the square root of 4, which is, square root of 4 is 2. So plus or minus 2. This is two roots, so be careful. This is positive 2 and negative 2. And then we set the other one, x squared plus 4, equal to 0. So subtract the 4 from both sides, square root both sides, inserting plus and minus. So x equals plus or minus square root of negative 4. We have to simplify this. We cannot leave a negative under the radicand. Remember, square root of negative 1 is I, and we can simplify both the square root of negative 1 and the square root of 4. This is still plus minus, but it becomes square root of 4 is 2, and square root of negative 1 is I. So my four roots, because this was x to the fourth, are going to be negative 2, positive 2, negative 2i, and positive 2i. If I was going to graph this, only two of these would show up on graph because we cannot graph imaginary numbers. Okay, on to number 7. Okay. This is x to the fifth, which we don't have a way to factor unless we start by factoring out a GCF. So each of these is divisible by x to the third. So when we factor out an x to the third, we get x to the third times x squared minus 21x plus 20, which is quadratic. Then we can solve this by factoring 20 on top, negative 21 on the bottom, so we get negative 20, negative 1. So my three factors are x to the third times x minus 20 times x minus 1. I set each of these equal to 0 and solve. If I cube root 0, one of my zeros is going to be through the origin. The other one set equal to 0 and solve will be at positive 20. And the third set equal to 0 and solve will be at x equals 1. Number 8, make sure that we delineate these. Check if there's a GCF. There is not. This is quadratic in form because it goes down from 4 to 2 to 0. So we can factor this with the x method. So 8 times 4, negative 32, positive 31. So we get negative 32 and positive 1. No, negative 1 and positive 32. And then, because a was not 1, we have to divide these both by 4. So this is 8. So my factors are, bottoms up, 4x minus 1. And this is going to be x squared because this was to the fourth. So we do our x method, but then our squared terms binomials have an x squared, and this becomes x squared plus 8. So these are our two factors. We have to solve each. So 4x squared minus 1, set it equal to 0, add 1. 4x squared equals 1, divide by 4. X squared equals 1/4, and then we square root both sides and take both the positive and negative possibilities. So x equals plus or minus the square root of 1/4. And we can simplify this more based on what we know about radicals, because what this really is the square root of 1 over the square root of 4, and both of those simplify. The square root of 1 is 1, and the square root of 4 is 2. So the answer to this part is plus or minus 1/2. So we have one root at positive 1/2 and one root at negative 1/2. Then we have to solve for x squared plus 8, set it equal to 0, and then do our math, subtract 8 from both sides. And we get x squared equals negative 8. Square root both sides, take plus or minus. So x equals plus or minus the square root of negative 8. We must simplify this negative 8. Split it into factors that can simplify. So negative 1 and 8 can be rewritten as square root of 4 times square root of 2. This will simplify, and this will simplify. So this becomes plus or minus. Square root of 4 is 2. Square root of negative 1 is I, and then times the square root of 2. So these are my 4 roots. If I was going to list them all out, I would say positive 1/2, negative 1/2, positive, I don't need to write positive, I can just say 2i root 2, and negative 2i root 2. And those are my 4 because this was quartic, so I can have 4 separate roots. All right, last one. This is also quadratic in form. So if we do our x method, negative 10 on the top, negative 3 on the bottom. So this is 5 and 2. It would be negative 5, positive 2. So remember, x squared minus 5, because this was to the 4th. So my binomials will have an x squared. And then x squared plus 2. Set each equal to 0. And solve. Square root both sides. Plus minus. So this one's just x equals plus or minus the square root of 5. This does not simplify at all. So we'll leave it there. And then x squared plus 2, set that equal to 0. X squared equals a negative 2. Square root both sides, plus minus. X equals plus or minus the square root of negative 2. We have to take this negative out and put it in front as an I. So x equals plus or minus I square root of 2. And this is 4 roots. Remember, it's positive root 5, negative root 5, I root 2, and negative I root 2. So it is 4 roots to our quartic equation. Okay, for this one, number, what is this, 10? It says to create a polynomial of the least degree that represents the graph below. What I am looking for here is I am just looking for that you can identify these roots, that you can identify the end behavior, and that you can identify the behavior at the root in order to write an equation. You can leave this in factored form, and that's probably going to be what's the easiest. Because we have both end behaviors going up, we know that this is going to be an even degree, and it's going to have a positive leading coefficient. So we can double check that when we're done. But I'm going to start with the roots. So we have 1 and x minus 4. To write that as a factor, we change the sign because the root is always the opposite sign of what it was in factored form. And because there's a bounce at that root, this quantity is squared. Then we have x plus 1. The graph is a little off, but we're going to go with the closest whole number. X plus 1, that's a cross, so that we don't have an exponent that we need to write because it's just 1. And then the last one would be at x minus 3, which is also to the first. If we add these up, we get 2 plus 1 plus 1, which is to the 4th, which is even, so that's good. And if we multiply all of our first terms, 1 times 1 times 1 is positive 1. So that is correct based on the end behavior. So this would be an accurate way to represent the graph with these roots and this end behavior. Okay, so 11 through 14 are dividing. So you have to use either synthetic or long division based on what you have in order to properly divide, making sure that your remainders are written in the correct form. So number 11, you have to use long division because we have this binomial where the coefficient of x is not 1. So we're going to set this up as long division. 2x plus 3, and then underneath 4x to the third plus 4x squared minus 19x minus 24. We're looking at our first terms. 2x times 2x squared would give me 4x to the third. And then 2x squared times 3 would give me 6x squared. I changed the signs of both of these to subtract. That goes away. 4 minus 6 would be negative 2x squared, and then bring down the negative 19. Now I am looking at 2x to negative 2x squared. I would multiply by a negative x. And then I get negative 2x squared minus 3x. Change the signs to subtract. So that one goes away, and this becomes negative 16x. Bring down minus 24. Negative 2x to negative 16, I am multiplying by negative 8, which gives me negative 16x minus 24. Change my signs, and I end up with a 0 remainder. So this is my final quotient. Number 12, I have to use long division as well because I don't have a coefficient of 1 for my binomial in the x term. So 3x plus 1 goes outside, and then 3x to the third plus 13x squared plus 19x plus 5. So starting with our first terms, 3x to 3x to the third, I multiplied by x squared. 3x to the third plus 1x squared. Change my signs and subtract. So 13 minus 1 would be 12x squared. Bring down plus 19x. So 3x to 12x squared, I multiplied by 4x. So 12x squared, 4 times 1 is 4x. Change my signs. 19 minus 4 is 15x. Bring down plus 5. 3x to 15x, I multiplied by 5. 15x plus 5. Change the signs, subtract, subtract. And I end up with a 0 remainder, meaning this is my quotient. Okay, number 13, I can do synthetic division because now I have a 1 coefficient of my x in my binomial. So I'm going to set this up for synthetic. 4, negative 15, negative 24, positive 1, negative 30. Remember, we always need to check that we have every standard form term as we go down. And if we don't, we have to put a 0 placeholder. But this one was good. So 4, multiply 20, 25, 5 times 1 is 5, 6, 30, yay. Okay, remember this is not our answer. This is not the end. We have to plug in x's, and it will always be 1 less degree than what we started with. So our answer is 4x to the third plus 5x squared plus x plus 6. And then 14, we can also do synthetic division here. So this would be positive 6. And then we have all of our terms in standard form. So we can start our... Okay, so bring down the 2 and then start multiplying. 6 times 2 is 12, negative 5, negative 30, negative 4, 6 times 4, negative 24. This is going to be 2 and 12. So we end up with a remainder of 10. So we need to write this properly. The degree is going to be 1 less than what we started with. So 2x to the third minus 5x squared minus 4x plus 2. Because it's a positive 10, we say plus 10 over our divisor, x minus 6. Okay, oh, goodness, that one's done. Okay, 15, you are figuring out if the binomials are factors, and then you have to factor completely to get all of the zeros. Both of these are in what the heck is it called? Synthetic division possibility, so we can just run the synthetic to check. So 3, we have all the proper standard forms. So 2, -1, -13, -6. 3 times 2 is 6. 3 times 5 is 15. 3 times 2 is 6. So this one worked. So this is 2x squared, 1 degree less than what we started with, plus 5x plus 2. So this is quadratic. We can set it equal to 0 and solve. And 4 on the top, so 4 and 1. A was not 1, so we have one more step to divide. So this one is 2. So x plus 2 and 2x plus 1 equals 0. So our two zeros are x equals -2 and x equals -1/2. This was to the third, so we have one more 0. Don't forget that this, what we did our synthetic division with, is also a root. So this was our factor. This is our root. So our three roots are -1/2, -2, and +3. Okay. This one's going to be a little dicier. Let's start with this because we can do the synthetic. So we'll do a -2, 3, -5, -17, 13, 6. So -6, -11, 22. This is going to be 5. 2 times 5, -10. +3, -6. Okay, so this worked out great. So this is 3, 1 degree less, x to the third minus 11x squared plus 5x plus 3. This is cubic, so we cannot solve it with an x method. We have to solve it with a different method. So how do we solve a cubic if we don't have any given factors? Well, we use this little technique, the rational root theorem, where we identify p, q, and p over q. So p are our factors of the constant term. So this would be plus or minus 1 and plus or minus 3. Q is the factors of our leading coefficient, so plus or minus 1 and plus or minus 3. Then we do p over q. So 1 over 1 plus or minus 1, 3 over 1 plus or minus 3, and then we put them both over 3, plus or minus 1/3, and then plus or minus 3 over 3, which is 1, which we already have. So we need to start testing each of these to see what works and to see if we can get it to a quadratic, when we can then just do either an x method or a quadratic formula. So let's try 1. 3, -11, 5, 3. -8, -3. Okay, so what a great, kind teacher you have that gives you one of the ones as a factor. So 3x squared minus 8x minus 3 equals 0. Start with the x, -9, -8. So our two factors would be -9 and 1. A was not 1, so we need to divide by 3. So x minus 3 and 3x plus 1. Set each equal to 0. So one is x equals 3. One is x equals -1/3. And then our two others are the ones that we found doing our synthetic division. So here we have 4 factors because it was quartic. So our not 4 factors. We have 4 factors. We also have 4 roots. So our roots are -2, -1/3, 1, and 3. That's least to greatest. You don't have to do it in that order, but it is nice to just have them go from least to greatest, left to right. Okay, this is more practice with rational root theorem. And again, I have given you more on this review than you'll have on the test. So I think I give you 2 here, and you had the one on 15. There's like 1 on the test. So the test is going to be a little bit shorter than the review. I just want you to see all possibilities. so that you have the practice to be able to go into the test and know what you're doing. So let's do our P and Q. P are the factors of my constant terms, so plus or minus 1, 2, 3, and 6. Q are the factors of my leading coefficient, so plus or minus 1 and 2. So then P over Q, these are my possible rational roots. I'm just going to put these here, save myself a step. All of these over 1 would be plus or minus 1, 2, 3, and 6. And then all of these over 2. So 1/2, 2/2 is 1, 3/2, 6/2 is 3. So those are my possible roots. Then I need to solve. So I'm going to start by checking my possible roots. So if we do a root of 1, 2, -5, -1, 6. So -4, this is not a remainder of 0. This is not a root. Let's try -1. So this is a root. So this is yay, green light. So we have one root is -1. And now, because this was to the third, this is quadratic. 2x squared minus 7x plus 6. Let's x this. So 12, -7. Let's see, 3 and 4. -3, -4, divide by 2, because a was 2, so -2. So we get 2x minus 3 and x minus 2. Set each of these equal to 0. X equals 3/2 and x equals +2. So these, along with the one we got from synthetic division, are going to be our 3 roots. So 1, 3/2, and +2. Okay, then we do it all again for letter B. Okay, P. Possible factors of my constant, plus or minus 1, 3, 5, and 15. Q, possible factors of my leading coefficient, plus or minus 1, 2, and 4. And then P over Q, these are my possible roots. So all of these over 1, 1, 3, 5, 15. All of these over 2, 1/2, 3/2, 5/2, 15/2. And then all of these over 4, 1/4, 3/4, 5/4, 15, yikes, I'm running off the page, 15/4. Those are my possible roots. Now, I'm going to start testing them to see what actually works. So let's start with 1. We can do synthetic, 4, 21, 32, 15. So 4, 4, 25. This is getting humongous. It's not looking good. Okay, I can tell this is not going to work. So this is a no. Let's try -1. 4, 21, 32, 15. So what is this? 21, 17, -17. So 15, and then minus 15. So yay, that is a root. 1 is -1. It's going to be one of our roots. So we can put that over here. And then this is quadratic, 4x squared plus 17x plus 15. Set equal to 0. And then this is going to be 4 times 15 is 60 and 17. So 12 and 5 multiply to 60. Divide by 4 because a was not 1. So I get x plus 3, 4x plus 5. So my other two zeros are x equals -3 and x equals -5/4. So I'll put those in, and then I am done. Okay, now we're getting into rationals. So those were polynomials. This was the second half of the chapter with rational functions where we have x's in the denominator. This is where you have to be able to identify everything about this rational function. This was the delta. If you did it by yourself, you've probably done this 6 to 10 times. If you chatted it, you've probably done this 0 times. So it is going to be tough, and you're going to have to learn it quick. All right, so remember, the first thing we start with is standard form. The two things we can find in standard form is we can identify the horizontal asymptote and the y-intercept. So before we do any factoring, we do those two first. The horizontal asymptote, we look at the degrees. If the degree on the top is less than the degree on the bottom, then we always have a horizontal asymptote at the x-axis. So we can say that our horizontal asymptote is when y equals 0. We also know that if there's a horizontal asymptote at the x-axis, we will have no x-intercepts because nothing can touch the x-axis because there is an asymptote there. Then the other thing we can find in standard form is we can find the y-intercept, which occurs when x equals 0. So we plug in 0 for all our x's, which leaves us with -3/6, which leaves us with -1/2. That is our y-intercept. After we do that, then we factor. So x minus 3 on top, and then on the bottom, 6, -5. This is going to be -6 and 1, right? No. -3 and -2. So x minus 3, x minus 2. Okay, so we can see that we have a common factor in the top and the bottom. That means we are going to have a whole when x equals +3. And I don't want you to tell me what x equals. I want you to tell me the coordinate. So when x equals 3, and then remember to find the y coordinate, we plug in x of 3 to whatever was left after we factor that out. So on the top is a 1. 3 minus 2 is 1, meaning the y-coordinate of that whole is +1. The last thing that we find is the vertical asymptote, and that just occurs when we have anything left in the denominator that is not part of the whole, that does not have a common factor in the numerator. So we will have a vertical asymptote when this factor equals 0, so when x equals +2. All right, let's do number 18. Okay, start with standard form. First two things we're going to find, horizontal asymptote, y-intercept. Horizontal asymptote, the degree on the top is bigger than the degree on the bottom. That means there is no horizontal asymptote. And then y-intercept, plug in a 0 for all of our x's, which gives us 4/2, which is 2. So our y-intercept occurs at 2. Now, once we've done those, we want to factor. The top is a difference of squares, x plus 2, x minus 2 over x minus 2. So you can see that we are going to have a whole when x equals +2, and then we plug this +2 back into whatever is on the top, or whatever is left that's not part of the whole. So the x-coordinate of our whole is going to be 2, and when we plug in a 2, to whatever is left, we get 2 plus 2, which is 4. So the actual location of our whole will be at 2, 4. Then vertical asymptote would be anything that's left in our denominator. I'm going to erase this and make it back to x. That is not part of the whole. We don't have anything left in the denominator. It was just that whole, so we have no vertical asymptotes. The x-intercept is anything left in the numerator that's not part of the whole, set equal to 0. So if we said x plus 2 equals 0, we get that our x-intercept will be at -2. All right, last one like this. Okay, start with these two, standard form. When the degrees are the same on the top and the bottom, we use their coefficients and just do the division. 1/1 is 1. So we're going to have a horizontal asymptote when y equals 1. And then to find the y-intercept, we plug in a 0 for every x. 0, 0, 0, 0. This gives me 0/6. Hopefully we've learned that by now. 0/6 is 0. So this y-intercept is going to be going right through the origin. Then we'll factor. The top, we can factor an x out of both terms. So this becomes x times x plus 3. And then the bottom, we can x method. So 3 times 2. X plus 3 x plus 2. Okay, let's start with the whole. The whole occurs when x is negative 3, because we set that equal to 0 and solve. And then we plug in negative 3 for everything else that's not part of the whole. So we take that x that's outside over negative 3 plus 2, because we plugged it in here and we plugged it in here. So we get negative 3 over negative 1, which is positive 3. So my whole will happen at negative 3, 3. Okay, then vertical asymptote is anything else left in the denominator that's not part of the whole. Set that equal to 0, solve for x. So we will have a vertical asymptote when x equals negative 2. X-intercepts are anything in the numerator that's not part of the whole, set equal to 0. So our x-intercept is also at 0, which makes sense because this is going through the origin. So if the y-intercept is 0, it's also going through the x-intercept of 0. But we can find it algebraically too. Okay, these next three are solving rational functions. So this is where we find the least common multiple and then clear the denominators. So for number 20, our least common multiple, the number that they all go into is 7x. So we're going to multiply every term by 7x and then cross simplify. So the 7's cancel there, which leaves us with 3x. And then the x's cancel here. Plus 2 times 7 is 14. And then the whole 7x cancels here, which just leaves us with 6. So now we can solve just using algebra. And we get that 3x equals 6 minus 14 is negative 8. And then last step is divide by 3. So x equals negative 8/3. Oh, I should have put that up here. Double checking that this plugs in, that is fine. That's not going to give us a 0 in the denominator, so we can say confidently that our answer is negative 8/3. Number 21, our LCM. First, I should factor this and write it in factored form so I can check what my least common multiple is going to be. So negative 4, negative, 2. So x minus 4, x minus 2. So my LCM, this goes into x minus 4, x minus 2. This goes into x minus 4, x minus 2. And then x minus 4, x minus 2 goes into itself. So my LCM is going to be x minus 4, x minus 2. So I'm going to multiply everything by that. Okay. And then start my simplifying and canceling. So x minus 2 cancels, and I distribute in the 3x to both. 3x squared minus 12x. Then the x minus 4 cancels. I'll distribute the 2. Plus 2x minus 4. And then on this side, everything cancels, which just equals 4. So if I combine my like terms, I'm going to add these two together. And I'm going to bring over the negative 4. So I'm going to get this all equal to 0. 3x squared minus 10x minus 8 equals 0. So I'm going to try to, this is quadratic, so I can try and do an x method. If your x method doesn't work, you have to do quadratic formula. 8 times 3, negative 24. Negative 10, this would be negative 12, positive 2. A was not 1, so we need to divide these both by 3. So we get x minus 4, 3x plus 2. Set each equal to 0. Our possibilities are x equals 4 and x equals negative 2/3. Always double check back to your original. If we look back, we cannot have x equals 4 as an answer because we would get a 0 denominator. So we are going to reject this, and our only solution is that x equals negative 2/3. Okay, this one, we only have one denominator. That means our LCM is that denominator. We're going to multiply everything by x minus 2. So every term by that denominator. This one simplifies, so we end up with 9x. This we will distribute, plus x minus 2, and then we also distribute the 6, equals 6x minus 12. So then let's start simplifying. This over here is 10x minus 2 equals 6x minus 12. Let's add 2. And we will do it all in one swoop. So this goes away. 10x minus 6x is 4x. Negative 12 plus 2 is negative 10. Divide by 4, divide by 4. Negative 10/4 simplifies to negative 5 halves. And that is fine. It can plug back in and not get a 0 denominator. So x equals negative 5 halves. All right, last one. This is a little bit more complicated long division. We do it the same way as all of our long division. It just has more terms. X squared minus 4x minus 1. 4x to the 4th minus 14x to the 3rd minus 5x squared minus 30x minus 7. So long division, we look at the first terms. X squared times 4x squared would give us 4x to the 4th. Then we are going to multiply every term by 4x to the 4th and write it underneath. So we get 4x to the 4th minus 16x to the 3rd minus 4x squared. Then we're subtracting, so we change all the signs and combine. So this becomes, this is to the 3rd, 2x to the 3rd, my goodness, minus x squared, bring down. Look at the first terms. X squared times 2x would give us 2x to the 3rd. 2x times negative 4x is negative 8x squared minus 2x. Change all your signs. Negative, positive, positive. So we get 7x squared minus 28x. Bring down the 7. To get from x squared to 7x squared, we multiplied by 7, and then we are going to do 7 times all 3 of these terms. So we get 7x squared minus 28x minus 7. Change all my signs. And then combine, combine, combine. I get 0 remainder. My quotient is then just 4x squared plus 2x plus 7.